Okay, today we are going to start a new chapter, linear regression. Okay, this chapter falls in under section C. Okay, you know section C is of 20 marks, out of which linear regression will come, you may say 6 to 8 marks. Okay, one of the most easy chapter. So now this chapter is a chapter based on statistics. Okay, as you all know, you have done a lot on statistics. So in class 10 you have done mean, median, mode, quartiles, ogive, histogram, so many things based on statistics. Okay, and it wasn't that difficult, it was easy enough. Okay, so statistical chapters are quite easy. In class 11 you also have done correlation, if you remember, Carl Pearson's method of calculating correlation coefficients, Spearman's rank. We had done this in class 11. Okay, so related to this chapter, linear regression, we will find regression coefficients in this chapter. Like correlation coefficient in class 11, we will learn how to find regression coefficient in this chapter. Okay, so let's come to the definition. What is regression? Regression is an estimate or prediction of unknown values of one variable from the known values of another variable. One variable is called dependent and the other is called independent. Okay, so let me let me give you an example. Okay, so the example would be, let's say I have this table. Okay, and this is physics marks, this is maths marks. Okay, let's say a student got 18, 19, 15 and 8. These are the marks obtained in physics, and 16, 15, 10 and question mark. Now, so what does regression do is, looking at these values, if you these values 18, 16, 19, 15, 15 and 20, and comparing them, we come up with this value, this missing value here. What should be the value? If a student who got 18 in physics can get 18 in physics can get 16 in maths, 19 in physics can get 15 in maths, and 15 in physics can get 10 in maths, then what will happen if he gets 8 in physics? What should be his marks? Let's make a guess. It's a prediction, it's an estimate. Okay, so that's how we learn regression. It will help you to find the missing value. Okay, missing value from the known values, from the values that we already know. Look here, for example, 18, 19, 15, 18, 19, 15, 16, 15 and 10. These three set of values are already known. Now we will find the missing value, this question mark, from the known value, that is 8. Okay, great. So regarding this independent and dependent, suppose you know if y equals to x plus 8, then y is called dependent. As you all know, this is called the dependent variable, and this is called the independent variable. Why? Because the values of y depends on that of x. Example, if x is, let's say, 1, then y would be 9. Is it? Okay, so the value which decides, suppose here you can see, here in this example you can see x decides the values of y. Okay, suppose if I write like this, x equals to y plus 9, then you may say y decides the values of x. Okay, y decides the value here. So in this case y becomes dependent, here x becomes dependent, here x is independent, here y is independent. You may say that way. Okay, you may put it that way. So that's how it works. Great. now okay, so we said that regression is an estimate. Okay, we predict it. Now how to predict? The problem is how to predict. What are you going to do to make the prediction? Okay, so please, by the way, keep your theory that I have already given just beside you so that you can refer to it. Okay, so now this prediction, whatever we are saying, or estimation, is made through equation of regression lines. Okay, now what are these equations of regression lines? Let's talk about that. Okay, so great. There are two regression equations. Okay, that means according to what we are saying, we Regression is an estimate or prediction. Okay, how do you predict that? By the help of regression equation. Now what are regression equations? We are seeing that. Okay, by the way, we know there are two regression equations. Okay, so what are the two regression equations? First, let's try the format of the equation. The format is, one is y equals to fx, the other is x equals to fy. Look at this regression equation. As you already know, in here in the first one, y is dependent, here x is dependent, here x is independent, here y is independent, by the way. Okay, so we put like this and write an independent, and we write this dependent. Okay, so the values of y depends on that of x, in the first one. In the second one, the values of x depends that on y. Okay, so these regression equations have names. What is this first one called? This first one is called regression equation of y on x. Mind it, it's written, it's called y on x. And this one, regression equation of x on y. It's called x on y. Okay, so how to recognize? Very easy. When you say y on x, see the order. When you say y on x, the first one, look at this one. Okay, let me underline. Look at this one, first one. When you say y on x, you have y in front and x later. X comes later. Okay, so that means y is dependent, x is independent. When you say x on y, then x is dependent, y is independent. That's how it works. Okay, so these are two regression equations. So there are two formats of regression equations. We're just talking in general, how do they look like? Okay, great. Next comes now to find regression equation by method of least square, if you see in your theory. Okay, so how to find regression equations? So what are the formula for regression equations? We'll try to find out that. So we'll write it down here. To find regression equations by method of least squares. So this method of least squares. So the name of the method doesn't matter much. Okay, so just remember, to find regression equation by method of least square. This is the name of the method. Okay, so how do you work it out? Let's see. Now number one, what do we have is number one is regression equation of y on x. Okay, so how to write regression equation of y on x? This is the format. The format is y minus y bar equals to byx x minus x bar. Let's name this equation 1. Okay, now you may wonder, what are these? Y bar, x bar. Okay, so these y bar and x bar, if you see here, the y bar and the x bar, these are means. What are these? Means. Okay, arithmetic means, you may say arithmetic means. And this byx is regression coefficient. We'll talk about it more. Regression coefficient. This is regression coefficient. Okay, so this is the format. So how to write, how to make regression equation of y on x? Y minus y bar equals to byx x minus x bar. These x and y, as you see, x and y are the variables of the equation. You got it, isn't it? Okay. Great. So now let me rub this. Okay, now the second one. What is the second one? Second one is regression equation of regression equation of x on y, man. X on y. So how does the regression equation of x on y look like? Very simple. X minus x bar equals to bxy y minus y bar. Okay, this is equation number 2. Okay, this was 1, by the way. This was here, I have it. This was 1. So, and this is here 2. Right, regression equation of x on y. So now again, let's come to this. What are x bar and y bar? These are means. What are these? Mean. Okay, and bxy, this is regression coefficient of x on y. By the way, if you have noticed this, Okay, in the okay, let me go down. This was regression equation of y on x. Let me rewrite it again. This was y on x. Y minus y bar equals to byx x minus x bar. And if you see, x minus x bar equals to bxy y minus y bar. Okay, look at this properly. When I say y on x, then y is right in front, x comes later. Similarly here, y front, x later. When I say x on y, x is right in front on the left hand side and y comes later. And here also the sequence xy. So please understand this properly. These are the regression, you may say regression equations. Okay, this is equation number 1 and this is equation number 2. Great. Okay, now how to find this byx and bxy. So first of all, now how to find these bx? What are these bxy and b? As I told you, byx equals to regression coefficient of y on x, and bxy equals to regression coefficient of x on y. Okay, the sequence, see, when I say y on x, I write y first, x second. When I say xy, I write x first, y second. Okay, so now these regression coefficients, so I can easily find the mean. You know how to find mean. Mean is add all the variates and divide it by the total number of observation. Arithmetic mean is very easy to find. Okay, now how to find byx and bxy? There are many formulas to find bxyx and bxy. Okay, and the first formula, the first very important and the basic formula is, you can find byx like this: byx equals to covariance of x comma y divided by sigma x whole square. Okay, what about bxy? Covariance of x comma y divided by sigma y whole square. Look at the sequence. When x comes later, by the way, I'll show you different color. When x comes later, then the denominator has x. When y comes later, the denominator has y, and both of them have covariance of x and y. Okay, so what is this covariance of x and y? You know, covariance is a joint variance of x and y. We have already done this in class 11. Okay, not so important. You will not be allowed to you will not be asked to find covariance of x or y. They will give you the value, you just have to put the value here. Okay, and sigma x and sigma y, you are very aware. Sigma x is standard deviation of x, and sigma y is standard deviation of y. You are already aware about this. Okay, so this is how it works for the first basic formula of byx and bxy, where byx means, what is byx, by the way? Byx means regression coefficient of y on x, and bxy means regression coefficient of x on y. Okay, so this is the first basic formula and understandings. Okay, let's quickly revise. So regression is an estimate, by the way. Let's come to the beginning. Regression is an estimate or prediction. How do you do that? By looking at the known values of the variable. We just find the unknown values of the by looking at the known values, sorry, we find the unknown values. Okay, by comparison. And usually while calculating regression, one value will be dependent, the other will be independent. How do you know one is dependent, independent? It's very simple. When the values of x depends on y, then x is dependent. When the values of y depends on x, then y is dependent. Okay, so how do you estimate this? Estimation is done through regression lines. Regression lines, how many regression lines are there? There are two regression lines. One is y on x, the other is x on y. Okay, y on x would mean y dependent, x on y would mean x dependent. Okay, then what is the format for regression equations? Y minus y bar equals to byx, x minus x bar. This is equation number 1. And the second one here, x minus x bar equals to bxy, y minus y bar. This is x on y. Okay, what is byx, bxy? These are regression coefficient of y on x and regression coefficient of x on y. How to find byx and bxy? Byx is given by the formula here, covariance of x comma y divided by sigma x whole square, and bxy is given by the formula covariance of x comma y divided by sigma y whole square. This is the first basic of regression, linear regression. Okay, great. Now let's go to something else. Okay, now what is the importance of this equation? By the way, let me rewrite this equation. Sorry. Okay, y minus y bar equals to byx x minus x bar. This was called equation number 1, if you remember, and x minus x bar equals to bxy y minus y bar. This was called equation number 2, labeled as equation number 2. Okay, now equation 1, this equation, by the way, this equation 1, if you see, this is used to estimate the values of y when the values of x is given. For example, let me, okay, suppose let's say this is y column and this is x column. Let's say 2 4 6 8, okay, and 1 2 3 and question mark. So what is missing here? X is missing, x is missing, the values of x is missing. So when the values of x is missing, which equation you have to use? Since the values of x is missing here, you have to use equation 2. Yeah, why? Because equation 1 is used to estimate the values of y when x is given. Okay, so maybe you got confused. Let me make another table where y is missing. So okay, this is y, this is x. So here you have 1 2 3 question mark 2 3 4 6. Okay, look at the first one. In the first one, what is missing? X missing. Let me write it down here, x missing. In the second one, what is missing? Y missing. Okay, so accordingly you have to use this regression equation. When x is missing, you have to use the equation where x is dependent. That means x missing means you have to use this equation here, second one, because x is dependent here. X is dependent. Only when x is dependent you will be able to find the missing values of x. And when will you use the first equation, equation 1? When y is missing, because here y is dependent. Okay, so equation 1, if you see your theory that I have given, equation 1 is used to estimate the values of y when x is given, and equation 2 is to estimate the values of x, the values of x when y is given. Okay, so when x missing, second one, when y missing, the first one. Okay, so that is there. Now okay, sorry, let me create some more space here. Okay, great. So now some more formulas, we come to some more formulas to find byx and bxy. Okay, so basically everything comes down to byx and bxy, because mean are easily you can easily calculate mean. Okay, but the problem is how to find bxy and bxy, because the regression equation looks like this. Let me show you again. Y minus y bar equals to byx x minus x bar. These things are very easy to find. Look at this, these things here, means are the circled ones, the blue circle ones are very easy to find. The problem is the problem you have is this black circle byx. Okay, or in the other one, x minus x bar equals to bxy y minus y bar. Okay, here also what happens, you can easily find the circle, black circle, because x bar and y bar mean means. These are mean are very easy to find. The problem is this green circle. Okay, green circle bxy, how to find bxy. So I would need some more formulas to find bxy and byx. Okay, so how? So there are many formulas. Let me start from the first one. The first formula is number 1. Let me use a different color. Okay, maybe red is better. Okay, number 1, when x bar and y bar are whole numbers, I may put it this way. Okay, no decimal, no fraction, whole numbers, then we are going to use this formula. Byx equals to summation x minus x bar y minus y bar divided by sigma x minus x bar whole square. That's the formula for byx. I'll make it for bxy as well. Bxy, similarly, summation, the numerator remains the same, x minus x bar y minus y bar divided by summation y minus y bar whole square. Okay, look at this, by the way, interesting. When y comes later, y is in the denominator. When x comes later, x is in the denominator. Okay, so this is how you will find byx and bxy. When will you use this formula? By the way, formula 1, when x bar and y bar are whole numbers. That means no decimal, no fractions, but very simple whole numbers. Then this formula would become very, very easy. Okay. By the way, what is the meaning of summation like this one? What is the meaning of, let me show you, what is this green one? What does summation x minus, what this means? First, you have to subtract x bar from x, y bar from y, and then multiply them and total. This is the total of the product of x minus x bar and y minus y bar. Don't worry, I'll teach you how to find these in when I do sums. Okay, that's formula number 1. Then formula number 2. What is the formula number 2? When there's a condition, when x bar and y bar are decimals, let me say, and x and y, that means the given data, okay, are small numbers. You may say single digit numbers. Okay, so when you have this situation, then we can use this formula. The formula is byx equals to summation xy minus summation x summation y, separately by the way, individually, divided by n, whole divided by sigma x square minus sigma x whole square divided by n. You can refer to your exercise formula, this thing. I have already posted the formula. Refer to those pages where for the theory, okay, if the formula is not clear here. Great. The other formula would be bxy equals to same numerator, sigma xy minus sigma x sigma y individual divided by n, same numerator, but since y is later, y comes later, so I will have here sigma y square minus sigma y whole square divided by n. So when are you going to use this formula? Very simple. When x bar and y bar are decimals and x and y are small numbers. Okay, this is the second formula. And the third formula and the final formula is when x bar and y bar are fractions, again are fractions, but x and y, that means the given numbers, are large numbers. Okay, by large numbers I may say 2-digit number would be considered as large numbers. Okay, by the way, second formula, use the second formula only if x and y are single digit numbers. Okay, so that's how it works. Great. And how does the formula look like? Very simple. Let me write down the formula for you. And the formula is byx equals to sigma uv minus sigma u sigma v divided by n, all divided by sigma u square minus sigma u by n, and here whole square. And the other one is bxy equals to same numerator, sigma uv minus sigma u sigma v all divided by n, and sigma v square minus sigma v whole square divided by n. Okay, I'll talk about this sigma u v later when I do sums. Okay, by the way, what are these u and v? Now the new things, where u is xi minus capital A and v is yi minus capital B. If you remember, what are these AB? These are assumed means. If you remember, in class 10 we used to do the mean sum by step deviation method, where we used to assume means. Same thing here. Even this third type of sum, when the numbers means are fractions and x and y are large numbers, what we do is we assume a mean and try to make the numbers smaller, okay, by taking help of assumed means. Okay, so this is the third and the third formula where we find u and b with the help of assumed means and make the column, you may say the data, quite smaller. Okay, so that the numbers will be small and the calculation would become easy for us. Okay, so that is how it works. Okay, let me give you one more formula, then I'll give you the fourth formula as well. Okay, and there is one more, the fourth formula and the final formula is byx equals to rho sigma y by sigma x. This is the most simple formula actually. And bxy equals to rho sigma x by sigma y. Look at this formula. Okay, what is rho now? Rho is correlation coefficient. Correlation coefficient, you have already done this. Correlation coefficient, correlation coefficient is usually given, we don't have to find. In class 11 we have already learned how to find correlation coefficient. This rho is correlation coefficient. Okay, and you already know what is sigma y, SD, standard deviation of y, and sigma x is standard deviation of x. So this is the most easiest formula. This formula will be used now. Every time I gave you a formula, I told you when to use it. So this fourth formula will be used when correlation coefficient and the standard deviations are given. Okay, the most easy formula that I have here. Okay, so these are the different formulas that we use to find regression coefficients. Okay, so that was the theory, the first part of the regression, linear regression. There are some more theories actually for regression, but I'll make another video for the second part. Okay, so now if you have understood this theory, go through the formulas that I have given, already sent it to you also. So go through those formulas also, and then look at this theory, the explanation. Once everything is clear, I will teach you how to solve sums on linear regressions. Okay, thank you.